Hello everyone, welcome to our channel Statisticians Hub. My name is Nihal Thakur and today we are going to learn how to perform correlation analysis in SPSS. But before that, let us understand what is correlation. Correlation is a statistical measure that describes the extent to which two variables change together. It helps us to understand the relationship between them. The strength and direction of this relationship are captured by correlation coefficients. We will get back to this correlation coefficient in the later stages of the video. So in today's lecture, we will mainly focus on two types of correlation. First is Pearson correlation and the second is Spearman rank correlation. So in Pearson correlation, it measures linear relationships between two continuous variables. It assumes a linear relationship. It is sensitive to outliers. It is calculated using actual data values. And lastly, it measures the extent of linear relationship between two variables. Here you can see the Pearson correlation's working formula. This is the formula that we use to calculate the correlation coefficient for Pearson. Now let's come to Spearman rank correlation. So Spearman rank correlation measures monotonic relationships. It's not necessarily linear. It does not assume a linear relationship. It is less sensitive to outliers and it is calculated using ranks of the data. Here you can see the working formula for Spearman rank correlation. This is the formula that we use to calculate the Spearman rank correlation. So now we have finished our theory portion. Now let's go to the SPSS software. So now in the SPSS software, as you can see, I have two variables, height and weight. So height is a numeric type variable. Since we'll be entering numerical values, we have taken the width 3, decimal 2, and we have labeled it as height, which will be measuring it in centimeters. And same goes for the other variable weight, which will also be a numerical value, and we have taken 3, decimal 2, and we have labeled it as weight, which will be measuring it in kilogram. So kg, and measure we have taken both as scale. So these are the two variables that we want to find the correlation. So if you want to know how I have entered this, how I have taken this measure scale, so there is already a video uploaded in the channel which you can check to get a deeper understanding how to enter the data in SPSS. So now coming to the data view, so this was the variable view, and by clicking here I can get to the data view, and in data view I have entered 13 values. So you can see here I have entered 13 values for height as well as for weight. So now I want to find the correlation between these two values, these two variables. So in order to do that, I need to go to analyze, then click on correlate. As you can, if you go to correlate, you'll see the bivariate option. So if you click it, you will get the two variables that you want to find the correlation. So first height is already selected, so just click this button and then height came here. Now go do the same thing for weight, click on this button, and you got the two variables that we want to find the correlation. Now correlation coefficient, as we have already discussed, Pearson correlation is something that we have discussed today, and the other one is Spearman. Kendall's tau b, this is another form of correlation that we will not be doing today. So we'll be mainly focusing on Pearson and Spearman. So test of significance, we'll keep it two-tailed, and we'll check the flag significant correlation. So now after this we'll click OK. So after waiting for some time, we will get the output window. So this is the output window. So here they have given us Pearson correlation, and this is the Spearman correlation coefficient. So these are the output, but in order to understand these values, we need to get to the theory behind it. So what does these values represent? So for that we need to get to the theory part again. So in order to interpret the output, we have to consider the following points. First is nature. There are two kinds, positive and negative. So if the correlation coefficient is positive, then we say that with the increase in one variable, the other variable will also increase. And if the nature is negative, so with the increase in one variable, the other variable will decrease. And The second point is strength. Strength, there are three kinds: strong, moderate, or weak. So as you can see, if the correlation coefficient values lies between this range, so for example, if the values lies between 0.7 to 1, so then we say that the strength is strong. And if it is lies between 0.3 to 0.7, then we say that the strength is moderate. And if it is less than 0.3, we say that the strength is weak. And the third is significance. So with the help of significance level, we can conclude the relationship is significant or insignificant. It means whether it is important in our context or not. So as you can see, we are following 0.05 significance level, that is 5%. So chances of error is 5%. If the p-value or significance value is greater than 0.05, we say it is insignificant. And if the p-value is less than 0.05, then we say it is significant. So now let's look at the output. So now, as you can see, we are in the output window. Here, for Pearson correlation coefficient, the value is 0.885, which lies between 0.7 and 1. So it is a very strong correlation. Second is significance. So here you can see the significance value is less than 0.01. So it lies between, it is less than 0.05. So it is a significant correlation. Second is this capital N. This N represents the sample size. As you have seen in the previous slides, that we have entered 13 values. So this is the sample size. And this is the correlation of height with weight. As you can see here, it is weight and here it is height. So this is the correlation of height and weight. And for the correlation of height with itself is always going to be 1. And this is in reverse order. Here the correlation is of weight with height, it is 0.885. It is the same as this value. And the correlation of weight with itself is going to be 1 only. So this is for Pearson. Now let's look to the Spearman one. So if for Spearman, the correlation coefficient is again 0.913, which is lies between 0.7 and 1. So it is also a strong correlation. Then the significance is less than 0.01. So it is also significant. And the sample size is 13. So for Spearman, height, the correlation of height with weight is significant and it is strongly correlated. And so for both Pearson and Spearman, we have seen that it is strongly correlated. The significance, it is also significant. So with this, I'd like to conclude my presentation here, and I hope you like the video, and please subscribe to our channel. Thank you.